Hello everyone, so here we are for our sixth chapter under the data science playlist, which is naive Bayes classification or naive Bayes classification. So here we will see that naive Bayes classification. So it is what is naive Bayes? It is a probabilistic approach. Naive Bayes is a probabilistic classification algorithm that utilizes Bayes' theorem to predict the class of a given data point based on its feature. And it is very simple and effective. It is known for its simplicity and effectiveness, particularly in text classification and spam filtering. Probability and conditional probability. So first, probability is the likelihood of an event occurring, and conditional probability, it is the likelihood of an event occurring given that another event has already happened, that a event which is already happened, pre-happened. So probability, probability, paternity, probability phasor, conditional probability, conditional the outcomes. So here we will see Bayes theorem. So under the naive Bayes theorem, we have posterior probability, likelihood, and prior probability. So Bayes theorem is the foundation of naive Bayes classification, enabling us to calculate the probability of the class given a set of features. So naive Bayes assumptions. We have feature independence that assumes features are independent of each other, meaning that the presence of one feature does not influence the presence of another. That if there are many different features, so the presence of one feature would not affect the another feature. And equal importance. Assume that all features contribute equally to the classification decision. So naive Bayes, the application of naive Bayes is spam filtering, sentiment analysis, and medical diagnosis. Naive Bayes is used in spam filtering to filter the spam. We know about the spam messages, and the sentimental analysis of a text data and medical diagnosis. Strength and weakness of naive Bayes. The strength of naive Bayes is simple to implement, fast training and prediction, effective for test classification. Then weakness, feature independence assumption, can be sensitive to data imbalance, limited handling of complex relationships. So we will import required libraries for naive Bayes classification. Then we will load and prepare the data, train the naive Bayes model, we will make prediction, evaluate the model, and so on. So there are like Gaussian naive Bayes which work well for continuous data. For continuous data we have Gaussian naive Bayes. Then for discrete data we have multinomial naive Bayes, and for binary data we have Bernoulli naive Bayes. So hopefully the naive Bayes classification is done here, and hopefully you guys are able to understand. Thank you.